So we're not lucky like the last time to have a 0 on the right, so I can't factor right away. So this is similar to having something like 3x squared plus 2x equals 1. To solve that, we would bring the 1 over to the left side and then try to factor or use the quadratic formula. So I'm going to bring that 1 over. So 3 sine squared theta plus 2 sine of theta minus 1 equals 0. So again, that's equivalent if you want to rewrite it with x's. Here I would ask myself, well, can I factor this? Is it possible to break this down and have 3x times x? That would be a 1 and a 1. And let's see if I put a positive here and a negative here. I'm guessing that might work. Let's see. So if we multiply that back out, that gives me 3x squared and then 3x times 1 and then negative 1 times x and then negative 1 and the middle term is 2x. Hey, this one factors. We got lucky. So they don't always factor. So just like that factors here, this factors here. So this would be parentheses 3 sine of theta minus 1 times sine of theta plus 1 equals 0. So if you don't see the factors with the sign in there, rewrite it with x's and give it a try. What do you do if it doesn't factor? We use the quadratic formula. So we'll try that in a second and see how that works. Once I have it written as a product equal to 0, I just break them down. So I have 3 sine of theta minus 1 equals 0 versus sine of theta plus 1 equals 0. Oops, 1 equals 0. So over here, I would add the 1 over, divide by 3. So sine of theta equals 1/3. 1/3 is not a special value on the points on the unit circle. So the best I can say for the first solution is sine theta equals the arc sine or sine inverse of 1/3. And then the other solution for the sine is always pi minus that one. So if that's theta 1, theta 2 is going to be pi minus that. And we'll double check that on the unit circle here. So remember, sine is a y value. So y equals 1/3 would be about there. And that's going to lead to this point here, or that point over there. And so this point here, this is what the arc sine tells me. The sine inverse. And then the other one, to get to that point over there, if I went around pi, but then backed up by that reference angle, that'll give me the other solution. And the reference angle is the arc sine of 1/3. So this other one is my pi minus the arc sine. This one up here, the other version, the other factor, sine of theta is equal to -1. So on the unit circle, when is y -1? That would be down here. So that would be what? Negative pi over 2 would be one way to get there. So theta equals negative pi over 2. And you could always double check that by using the arc sine on -1 or the sine inverse on -1, but we should be familiar with that angle right there. So that would be one solution there. We could do a positive version of that angle by sweeping around like that. So that would be 1 pi over 2, 2 pi over 2, 3 pi over 2 would be another version if we wanted one. Let's see, we could call this theta 3, theta 4 would be, what did I say, 3 pi over 2. And then we could just keep spinning around the circle, adding or subtracting periods from either of these. So here we're able to get nice exact answers. By nice, I mean it's got pi in it, pi's nice. Over here, sine inverse of 1/3 isn't a number I'm familiar with. The best I can do is plug that into the calculator. So let's plug that in and check these. So first thing I want to do is I want to get the sine inverse. So I think one solution, let's call it A, equals sine inverse, or you could just type arc sine 1/3. So it's about 0.3-ish. And then my other solution, the second one, I'll call that B, that was pi minus, 0 pi, there we go, minus that solution above, which I called A, so I can just type A. So those should be two of the solutions, and the other two solutions I found were negative pi over 2 and 3 pi over 2. And let's graph this to see. So I had my original equation was 3 sine squared of, and we have to use x's here, plus 2 sine of x. So that was the left side. That's a cool looking wave, huh? And that was set equal to 1, so I would compare that to y equals 1. And so for solutions here, this one right here should be my arc sine of 1/3. Over here, that is my pi minus that. And then other solutions like this one right here, that should be the negative pi over 2 we found. And if I scroll over, this one right here, where it hits at its peak, that should be the 3 pi over 2. And then we can just get multiples of those solutions, or sorry, we could extend those solutions with multiples of the period if we wanted more solutions. And on some of these problems, we're going to try and find all solutions. On other ones, we'll just look in a certain region, like maybe we'll be asked to find all solutions within one period from say 0 to 2 pi. So if that were the case, let's go back. So if we only wanted solutions in that interval, then we got to be a little more selective. So for example, we don't want a negative answer right there. These two came out to be positive, about 0.3 and then 2.08, I think that one was. So for sure what we're getting is the first one we found and confirmed on the graph was that sine inverse, which was 0.33 something. Let's look back at the calculator. 0.3398, let's go with that. And then the next one was that symmetry version, so 2.8018. And then I can't use this negative version because I'm looking for positive solutions. So the next one down the road would be the 3 pi over 2. So comma 3 pi over 2. And then to check if there's any more, the next one after this one is going to be 2 pi later. So that's too far outside the interval. The next one from this here is going to be 2 pi later, which would be outside the interval. So I think I should have all of them, and we can double check that on the graph. So 2 pi is a little over 6. We could graph it to double check. X equals 2 pi. Hang on a sec. My kitten is trying to do math with us here. Back off, little buddy. All right, so here I can see the cutoff for 2 pi. And so I have that sine inverse solution here, pi minus that one there, and then the 3 pi over 2, and then that's the 2 pi right there. And so the next one's outside of my interval. So I have 3 solutions from 0 to 2 pi. And based on those, I can get as many as I want using multiples of 2 pi added or subtracted.